Hello guys, welcome to session 3 of Wi-Fi pen testing bootcamp. Uh, just so that I know you guys can hear me clearly, please drop a message in the live instructor interaction channel. Just say hi or hello or something so that I know that you guys can hear me clearly. Okay, okay, yeah, thank you. Okay, so guys, let's start with today's topic. So just to recap, in the first two sessions, we talked about Wi-Fi basics, protocols, the WLAN header, how to perform sniffing, what kind of setups you can use, what are the advantages of your modified access points over your USB-based adapters. And then in the second session, we talked about the secure networks. We started with the WEP network security. We talked about how WEP works and what was the reason of its downfall, how to crack WEP in the access point as well as AP-less setups using the cafe latte attack. Then we moved to WPA PSK. In that also we learned how to use this, how it actually works behind the scenes. And then we also observed that if you are using a weak password, even when WPA PSK does not have any issues with the protocol, due to the easy password that we are using, it is again vulnerable to your offline dictionary attacks. So you can use a good password list and you can have a very powerful infra with you, and you can then still recover this password. Today we are going to focus on the enterprise side security. So we are going to talk about the EAP part or the enterprise part. But before we do that, let's take a look at the assignment. So last time there were two kind of assignments, and it is the standard for all of our sessions. Every time we have two kind of assignments. The first kind is the lab-based assignments, in which you are supposed to cover the labs that we have covered in the session. So for that, I actually add the links to the labs in my slides. So you can just click on them and you can play them. And every each of those labs, they come with their own solution manuals. So if you are stuck somewhere, you can either refer to that. You also have access to the Discord server that we have for this bootcamp. So you can ask me questions there if you have any questions. That is the first part. I hope you have covered that. If you haven't, please try to do that, because till the time you don't try it on your own in the lab, you won't get that confidence, you won't get that clarity. That's the first part. The second part of the assignment is these questions that we give, so you can think about it, and when you are thinking about these on your own, it will bring more clarity to whatever we have covered, to whatever we have explained, right? So these were the assignments. The first question was, if you remember, when cracking web, we were talking about these weak IVs. IV is initialization vectors. These are those random strings that you take, you add it with the key, the static web key, and then you get a 64 or 128-bit key out of it. You pass it to the uh, RC4 algo, and RC4 algo then gives you a key stream, right? So we were talking about that, whenever we are trying to crack the WEP, there are some weak IVs which the algo can leverage, and it can then recover the key material for the key, and eventually it will recover the whole key. So first question was, what are these weak IVs and how do they leak information regarding the key? That was the first question. Again, to understand this, you will need more information about how your key derivation actually works. So how all of that construction works. So I have added a explanation to a really good video here. So you can go through this. It's actually a 20 to 30-minute video. So if we try to explain it during the class, all of time will actually go into that. And it is not that important, from your perspective, from a practitioner's perspective. So if you're interested in knowing, you can check it out. If you think that anywhere, it's not making sense, you're not able to keep up with what the guy is explaining, just let me know, and I'll help you out on the Discord. So that was the first question. Second question was how to crack a WEP encryption if we don't have enough packets, right? So if you remember, whenever we were cracking WEP scheme, whenever we were recovering the key for web, uh, our procedure was pretty straightforward, and it is same for the AP attack and the AP-less attack. So we used to gather a lot of these data frames which are web encrypted, and then we were running our algo on it. When I say we, I mean our tool, that is aircrack. And aircrack is then looking at these web packets, and because there are so many of web packets, it will be able to find the weak IVs, and then it will be leveraged to crack the web. But what if we don't have that many packets, right? So what if we only have 100 or 200 or 300 packets, right? How we can do it? So in that case, we can again fall back to the dictionary attack part. So we have this lab here. It's called WEP Cracking Advanced Lab. It's available. So in this one, we have used a Python script to actually perform a dictionary attack on the WEP packets. So that is something that we can do if for some reason we are not able to get enough packets of a WEP uh, scheme. So that was the second question. The third question was why we are not using web with 64 or 120 bit key directly, instead of taking 24 bit of IV and then taking 40 or 104 bit of static web key, right? So why not to directly go for the 64 or 128? uh, I think by looking at this construction here, how web works, how web encryption works, it will be very clear to you. So if you take a look at this construction, you can tell that for each packet, right? For each packet, what we are doing, we are actually taking this key here, that is the static web key, and we are taking the IV, that is 24-bit long IV. It's a random thing. You just select it on random, and then you are passing it to RC4, and then because your seed is different, the random key stream is different, and then you are applying the XOR operation with the data and the ICV, which is again a checksum of data calculated on it, and then you are getting the ciphertext. Uh, Now, because you have a 24-bit component which is changing every packet, right? For every packet you are actually using, or for every frame, I'll say, you are using a different IV. So for that reason, your seed is different every time, and you are getting separate and different random key stream for each frame. However, if you directly go for a 64-bit key, and if you don't use IV, this seed here is going to be same for all of the frames, right? You don't want that. Why? Because if you have this random key stream same every time, right? If it is same every time because of the same seed, then if you have two packets or two frames which are like which are same or similar, then in this case, because the key stream is also same, you are going to get identical ciphertext here. That is something that you don't want, because once you have that, then there are a lot of statistical attacks that can be done on it, right? So you don't want that. That's why we are using a 24-bit IV or the initialization vector to add the random component. The next question was how to decrypt WPA to PSK traffic with air decap NG. We have also covered it in the previous session's slide. It was more to give you something to think about. But again, we have already seen this air decap NG tool, right? If you check the help option for this, you will actually see that it provides you an option to decrypt the WPA specific packets, right? So you just need to define the SSID, and after that you can use -p to pass the passphrase, and then you can give the PCAP name, and it will then automatically identify this WPA SSID based on the SSID name and based on the security setting, and then whichever data packets, whichever data packets are from this specific SSID, those will be decrypted. The last question was, you have captured a four-way handshake for WPA to PSK network, but for some reason you were not able to capture any beacon frame of that network. Again, this question is totally hypothetical, right? Uh, how this can be the case, right? Because you just captured the four-way handshake also, so which means the client is already there, right? So how you are not able to capture the beacon frame? So again, this is a totally theoretical question that we have. This is a totally theoretical as well as imaginary question, imaginary situation that I have put in just so that we can cover this corner case. So in this case, we have a dictionary file which has correct secret passphrase in it. The only thing that we don't have is the SSID name, right? So what we can do in this case, will our tool aircrack ng work on this? If not, what to do? So in this case, because we don't have SSID, so aircrack ng directly won't work on this. It won't be able to identify the network. It won't be able to do anything because if you remember, right, how the dictionary attack works, you need SSID, because if you don't have SSID, you cannot calculate the PMK. If you cannot calculate the PMK, you cannot calculate the PTK, and then so on. You won't be able to verify which one is the correct one. So what you can do in this case is you can take a popular SSID word list, and then you can generate the PMK list using genPMK, because you have the list of passwords with you, right? So you take list of SSIDs also, and then you generate corresponding PMK list, and you pass this PMK list to our aircrack ng, and now aircrack ng will be able to use this PMK list to generate the PTK, and then the PTK can be divided into smaller parts, and a portion of PTK can be then used to verify the packet, right? Verify the MIC, and then you will know that it is the correct answer for this specific SSID. Any doubts still here, guys? Anything that you want to ask, anything which is not clear, you can ask. Okay, so it looks like there are no questions. Please feel free to ask any questions at any given time. So now let's start with today's topic. Before moving to the enterprise networks, let's first learn what were the reasons for us wanting the enterprise networks, right? What is the need? So what were the shortcomings of the personal networks? So personal network is your WEP, WPA, PSK, WPA2, PSK, right? So what are the problems with these networks or these schemes? First problem is the passphrase or the static web key, right? It is same. And with web, we actually have a way bigger problem, right? Doesn't really matter which password you are using with web, you're always vulnerable, right? So we can keep the web out because web is anyway not secure. You cannot use it. So let's talk about WPA to PSK, which is good enough, but it is not able to serve all the needs that we have as an enterprise, environment. So first problem is you have same passphrase for all the users, which means if any one of the user leaks the password, or if any one of the user is leaving the group, now you have to change the password for everyone, right? So that's the problem. Second one is insider attack. So anyone with a valid password, right? So any legitimate user, because he has access to the password or the passphrase, which is same for every user, he can then make sure that when a client is connecting to the access point, he can capture the handshake. Once he has the handshake, once he has the passphrase, he can then decrypt any other party's traffic if that party is also connected to the same SSID, right? So it's a malicious insider attack. One of your guys is actually trying to spy on other people, so he will be able to do this. Third problem is there is no forward secrecy. So this means if we capture the packets for a WPA to PSK network today. So we are making a dump, right? We don't know the passphrase for it, and at the same time we have uh, started this dictionary attack on a powerful setup in the parallel, right? And because the password is reasonably secure, we are not able to crack it, but the dictionary attack is running. And as we know, dictionary attack or the brute forcing attack, which is the superset of the dictionary attack, it will eventually succeed. It's just a matter of time, right? So suppose for 2 years we were capturing all the data that is being exchanged between the clients and the access points using WPA to PSK network. After 2 years, suppose we were able to crack the passphrase, and now we have the right passphrase for that network. Now the issue is that even when we are able to get this passphrase 2 years later in the time, we still be able to decrypt all the traffic that we have captured for these 2 years. So that is the problem here, right? So you don't want that. What is the next problem? The four-way handshake that is there, it is susceptible to the dictionary attack, right? You can capture the four-way handshake, you know the SSID name, and now you can use something like a aircrack ng with the dictionary file or with the brute forcing file, right? Uh, or with a brute forcing pattern, and then you can try to perform the dictionary attack on it. So again, the password, if it is not secure, you are a goner. You cannot do anything. The last problem is secret, right? This secret passphrase, it is available on every access point. So even if one of the access point is compromised by some way, uh, if by physical access or by some other vulnerability, if one of the access point is pawned, your secret passphrase is now with the attacker, and now he has access to all of the network. He can decrypt everyone's traffic, right? All of that things he can do. So these were the shortcomings of the personal network. And again, some of these are not really shortcomings. These personal networks were designed for the personal networks, right? As the name suggests, these were supposed to be used on the networks which you consider to be your own uh, in nature, right? So, for example, home network, where you have a family, using it. So you are not really trying to hide everything from the other parties on the network. However, that will not work in enterprise, right? So how we can fix these issues? First issue is same passphrase. So if we have separate passphrase or separate passwords for everyone, this will be solved. For the insider attacks, again, the separate password will solve it for this issue too. Third one, for the forward secrecy, if you remember why this is a problem. This is a problem because your PMK, right? Uh, the pre-master key, that is PMK, right? It is being derived from your SSID and from your passphrase, right? So if I just enable the drawing here, yeah. So here you have your SSID, and then you have your passphrase. You take both of these, you put them into a password-based key derivation function 2, and then this gives you PMK. And then you use PMK plus four-way handshake to generate PTK, which will be then eventually used for all the encryption and all the verification, right? So what's the problem here? Problem is your PMK is being derived using the passphrase, because we were talking about that 2 year in the future thing, right? So at that time also, if the passphrase is same, and because the SSID is also same, right? Uh, it is going to give you the same PMK. And because the PMK is same, you just need a four-way handshake in the capture, not A. For all the clients, you will need a four-way handshake, right? And then by using this, you can derive the PTK and you can actually decrypt all the traffic. So that's the problem here, right? So This is because our PMK is being derived using our passphrase, right? Passphrase is responsible for this, in addition to SSID. So if somehow we can break this dependency, then if we can use a random PMK, then this thing won't work, right? This issue will actually go away. Similarly, this one will also go away, because as we just saw, right? Because of this relation that PMK is derived from the SSID and the password, we are able to run the dictionary attack, and then we are able to uh, recover the correct one, right? However, if our PMK is random, we cannot actually run a dictionary attack on it. Means we can try, but it will be very difficult to actually get it right because of the degree of randomness, right? So your PMK, right? It is a 256-bit key. Now think, if you have a 256-bit string which is pretty random, you have 2 raised to power 256 combination, right? This security is actually same as the AES 256, and this is kind of unbreakable for now. So if you have that kind of security, this problem of having the issue of dictionary attack will actually go away. Similarly, in the third one, you have secrets on every AP, so the attack surface is larger, right? That's the idea here. So you have in the corporate environment, you will have multiple access point. One access point will be here, another is here, another is here. So if any one of these is compromised, you actually get access to passphrase, right? How about if instead of storing these on all of these machines, right? If you have multiple access point, however, if you have a centralized DB, which is being used by these guys to authenticate the user, now you have all the secrets at one place. Obviously, it can also become a single point of failure, but having everything at same place gives you more leverage on this information. You can harden this system, right? You can monitor this system, just like we have Windows Active Directory, right? You have one master server, that is domain server, and then you can protect it, you can monitor it, and you can make sure that nothing happens to this. So if we can do something like this issue will also go away, right? So that is what we have learned here. Now let's talk about WPA, WPA2 enterprise, right? So in WPA, WPA2 enterprise, and you can remember, right, the first two things, right, our station, that is our client, and our access point, it is still there in the WPA, PSK, and WEP, right? These two tiers were already there. These two components were always there. These were there in the WEP as well as in WPA or WPA2, right? In the enterprise part, we are actually adding this new component here, which will be known as Radius or AAA server. AAA stands for authentication, authorization, accounting. So the way this will work is, this is your station, and this guy access point is hosting a Wi-Fi network, right? Now, when this guy wants to connect to this, unlike your personal networks, uh, when this guy wants to connect to this, he has to authenticate against the Radius server. So through this machine, through this access point, it will actually talk to this guy here, and then this guy is going to verify this guy. And once Radius is able to verify the station, after that, the station can then connect to access point, and then it can use internet, right? So that is what is changed when we talk about the enterprise network, WP enterprise network. Okay, so let's move to the next slide. This is your Radius server. Radius is a pretty old protocol which is used to authenticate remote users. It is there from the time of dial-in. So your A radius server is also known as AAA server, as I was mentioning. AAA stands for authentication, authorization, and accounting. There are a lot of paid options when it comes to the radius server, but one of the popular free and open source option is the free radius. So if you want to implement a radius server, at your place, you can actually use free radius. Now most of the access points, right? Now the Soho access points, your D links and TP links of a little bit higher range, higher price range, they actually come with their own inbuilt radius server. So you can also use that. If you want to use this among multiple machines, then you can use free radius. You can just install it. And now I'm very sure that it must be also coming with the Docker container support. So you can just deploy the container and then you can configure it to be used. So now let's talk about EAP, or the Extended Authentication Protocol, right? Uh, so here it is important to understand that EAP is a way by which two parties can authenticate. So it's an authentication framework. It is defined in this RFC. If you are interested, you can take a look. Now, EAP has a lot of authentication protocols, right? It's a very big framework. It is not specific to Wi-Fi. It works on LAN and all other kind of networks, right? However, a small set of EAP is adopted for 802.11, that is Wi-Fi, right? This is our beloved WLAN or Wi-Fi. So this part is known as 802.1x, right? So this is what we are going to focus on, not the whole of it. We are going to talk about different methods, encapsulations that are there in the 802.1x and that we can use. So now again, this is the same diagram that we saw, but this is more detailed with the parameters given here. So there are two connections, as you can observe here. This is the first connection. This is the second connection. This connection is going to be wireless because this is the SSID that you have created using this access point. This guy here is going to have this wireless card, and it is also going to connect to this guy. However, this connection here is going to be over wired LAN. So this is wired connection. This is wireless connection. And on your wired network, on your wired backbone network, you are going to have this AAA server, which will be used for the authentication, accounting, and authorization, right? Now, in order to make sure that only authorized access points can talk to this guy, right? There is no fake access point which is actually making fake requests and all. To avoid all of this, we have these settings present on the access point. So what are these settings? First one is the server IP, that is IP of this server here, AAA server. Then there is a shared secret. Obviously, again, because otherwise, how this guy will validate if this guy is the real one, right? So once, because it has the shared secret, whenever this guy is going to send message to this guy, he can authenticate that it is coming from a valid client or valid access point. Then there is authorization port and accounting port. These are just the logical port numbers of this machine where authentication as well as accounting services are running. So this is the setting that is done on the access point side for the AAA connection. And then on the AAA side, you have client IP, that is IP of this access point here, and then the shared secret. So this guy, this configuration, shared secret is same on both sides, right? So this thing is same to this thing. Both parties have this, so they can authenticate each other. A very easy and very basic way of authenticating each other. So this part is secure because of this setting. Now, when we are talking about the supplicant or the client or the star, that is station, and the access point here, this side to authenticate, right? You will have the ESSID, that is name of the SSID. Then you will have information about the authentication scheme, and then you will perform data encryption when you will connect it to this guy over the wireless network. And same information is on this side also, right, to make the connection. So yeah, let's clear this. Okay. So this is your 802.1x. This is how it looks when the authentication is done. So it's pretty easy to follow. You have your supplicant here, right? This is your supplicant or your client. You have access point here, which is known as authenticator. AP is known as authenticator. This is known as supplicant. You can also call it STA. And then this is your radius or AAA server. Uh, so we have already learned how when you connect to a station, when as a station you are trying to connect to an access point uh, in an open network as well as in a secure personal network, you actually exchange a lot of packets with it, right? So if you remember, whenever we were trying to do that, first the discovery phase was there. In the discovery phase, using the beacons or the probe request and responses, the STA or the station knows about this access point and the BSS ID that is there. After that, they exchange authentication packets from both sides, right? First packet is sent by the client, second packet is sent by the access point. After that, they exchange association packets. So first packet will be sent by the client, the second packet will be sent by the access point. And after this much has happened, after that, in case of your personal networks, the four-way handshake actually comes into play. And when we are talking about the open network or the WEP, directly the data exchange is started. In case of open networks, the data exchange is not encrypted. In case of web, it is encrypted, right? And in case of your WPA to PSK, WPA PSK, after the four-way handshake, you start the data exchange with encrypted frames. But now in this case, what will happen? Once the authentication and association packets are exchanged, after that, this client here will ask the access point to start the EA poll. EA poll stands for Extended Authentication Protocol over LAN. That is what EA poll stands for. So this guy is asking to start the EA poll. Access point in response will ask for its identity. Now, what is the identity? Identity is the username. It is the username. And how this guy will know the username? Because its user, the human that is operating this guy, right, will provide it that. Uh, and in response to this identity request, this guy, this machine is going to provide the identity, the username, right? Username of the user that is going to authenticate with this system. This identity is passed to the AAA server, right? Again, these dotted lines, they mean this connection is a Wi-Fi connection. This is your wireless connection. This connection here, it is the wired connection. So packets are going on the wired network. So this identity is forwarded to the AAA server, and this connection is through the access point. So access point is first seeing this packet, and then it is forwarding this packet to AAA server. So once the identity is given to AAA server will then start the EAP auth. So now it will then send some EAP related packets, and we will go into detail of that later. But you can think of this as a challenge packet. So this is a challenge packet that is sent to the access point. Access point is going to send it to this guy here, right? Uh, in some cases, it is directly the challenge packet. In some cases, it is some other EAP packets to establish a secret connection with the client. So this line here, right, that we are seeing, this actually signifies a end-to-end tunnel with the client and the AAA server. So in some cases, this is also created. Once this is created inside this tunnel, then the challenge is provided by the AAA server to the supplicant. If the supplicant provides a response which is valid, then AAA server will tell the access point that, okay, the authentication has succeeded and you can then move forward. And at this point, through this tunnel, the AAA server, it will generate a random PMK. Random PMK is generated, and it is given to the client through the tunnel, through this secure media. And we will talk about this, what it is, don't worry. This is just a overview of the process. And then the same PMK is also given to the access point. Why? Because obviously they both need the shared secret, right? Once they have the same PMK, then they will perform the four-way handshake to generate the PTK on both sides. And once the PTK is generated, after that, you already know that TK is a part of PTK, which will be then used to encrypt the data. So that is how it is going to be done, right? This is the process by which authentication is going to be performed. So if we move to the next slide here, you will actually see that all the issues that we had with our personal networks, right? Our WPA2 personal networks, uh, all of these are now taken care of by our enterprise networks. How? If you talk about the first thing, now we have credentials, and these credentials are specific to each user. Each user is going to have a username and a password, right? So even if someone has leaked his password, the attacker will only be able to access whatever this user can. Similarly, if an old employee is leaving or a new employee is coming in, you can just revoke his credentials and issue the new credentials to the new employee, right? Easy to manage, just like AD. Then for the insider attack, because PMK that is being created in this case, it is random, it is not derivable, it is being generated by the AAA server on random, right? So you cannot actually generate the PMK for the other party. So suppose if this is your access point, right, and these are two clients, now because for both of these guys, the PMK is different. And this is totally random. This is sent by the AAA server that is sitting on the LAN. So because of these separate PMKs, one guy cannot guess or derive the PMK of other guy or other device, right? So this insider attack won't work. Similarly, the forward secrecy is also there because PMK is not derivable, right? It is generated on random. You cannot generate it again in the future, right? And when it is passed on secure media. So for example, for access point, it will be passed on the LAN, right? And that too in a protected packet. Whenever it will be provided to the client, it will go over the WLAN. But if you remember, it is an end-to-end connection with the AAA server. So you cannot see this traffic and figure out PMK. That is not possible. So you cannot recover PMK. And due to that, the forward secrecy will be there. Similarly, the handshake dictionary attack, it won't work because PMK is too random to attack. You can try, but you won't succeed. And the last thing, we have moved all the credentials to the Radius server, which is more protected, more monitored, and all of that, right? So more secure in one way. So guys, any questions till now? Any doubts, any questions, anything that you want me to repeat, just let me know in the live instructor interaction channel. All good? Everything is clear by now? Okay. Okay. Great. So we can move to the next slide then. Okay. Cool. Okay. So yeah. So let's talk about 802.1x. Okay. So when we talk about 802.1x, there are two things that we are going to talk about. First part is the authentication methods, right? So these are the methods that you will use to authenticate the remote party against the first party. So two parties, they want to authenticate each other in some case only one party is being authenticated. It totally depends on how the scenario is and what the need is. But the idea is that when you want to authenticate another party over a network, you are going to use one of these methods. Again, these are taken from EAP. These are EAP, but this is just a subset of EAP. It's not all of the PEEP, right? So example of such authentication methods are EAP MD5, EAP PAP, EAP GTC, EAP CHAP, EAP MS CHAP v2, right? Don't worry if you are not able to, see what it is, where we are going. Don't worry. Once we take an example, it will be very clear to you. So we are going to talk about a very simple way of authenticating the other party, and that is by using EAP MD5, right? And from the name itself, you can tell that it is going to use MD5, right? And that much is clear. So what you have here, this peer is nothing but your station. Access point is already labeled as access point, and this is your AAA server, right? So what all is happening here? Now here we have omitted the first Wi-Fi, packets or frames that we have to exchange, like the authentication or the association, right? Packets. And after that, this is the EA pole start. So EA pole start is sent by the station to the access point, and access point is then requesting for the ID. ID is your username. Username is your ID. ID is provided. ID is given to the Radius server. Radius server is now issuing a challenge that is using MD5. And that's why the name of the scheme is EAP MD5, because it is using MD5 here, right? So this challenge will be given to the station, and it will come through the access point, obviously, because it is this part is wireless and this part is wired, right? Here to here it is wired, and from here onwards it is wireless. So once the challenge is given to this station, the station is going to create a response, right? And what is this response? Response is the MD5 hash of response ID. Don't worry about response ID. We will actually see where it is. The password and the challenge that is issued to this guy, right? So this is challenge. So when you take all of these three, you actually concatenate these and you calculate MD5, this will become your response. So response is calculated, response is sent back here. Response will be given to AAA server. Now AAA server, because AAA server already has the password, right? Response ID is also known to it. Challenge is generated by him itself. He can also calculate the same thing on his end, right? Because everything is known to him also. So once he will generate this response, he will then match the response that is generated by the AAA server and that is provided by the client, right? So response generated by the client, say RC, and response generated by AAA. Now, if this is same, which means the password is same and the user is authenticated, the EAP is successful. If it is not equal, then it means that the user, because again, we are authenticating the user here, right? We already know that the AAA server records are good. So if it is not matching, we know that the password provided by the client is not good, right? And it is not the valid user, right? And so we will actually issue a EAP failure message to it, and access point will then kick this out. It will not let the station connect to it, right? So this is how it is going to work. So let's Okay, yeah. So this is how this will work. Again, let's go into more detail. Let's see how the packet flow is. And for that, I'm going to share another screen with you. So just a minute. This is a packet capture of EAP MD5. And as you can observe here, we have, this is the client, and this one is the access point. The Netgear is the access point. And okay, sorry. Here the Netgear is the client, and this one is the access point. And if you want to confirm that part, what you can do, you can actually open this frame here. You can check the BSS ID. And if you check the BSS ID, you will actually see that Buffalo, this Buffalo is the BSS ID, right? So this guy is the access point here, and this guy is our client. Now, again, you won't be able to see all of it. This is just the wireless side of it, right? So that's why you are not seeing anything coming from the AAA server, because this is a wireless capture, right? We are only seeing the frames on wireless side. We are not seeing the interaction that is going between access point and the AAA over the LAN, over the wired LAN, right? You are not seeing that. So now this is your 802.1x authentication packet, right? As you can observe, the protocol is EAP. If you open it, it will tell you that, okay, the type is EAP packet, the length is 5. Now, if you open this, you will actually see that it's a request for the identity. So this is being done by the access point. In response to this, our client, that is our Netgear, is going to provide the identity, right? So you can see response, the length is 20. What is 20 here? This thing, right? So you can see it's the 15 byte long. Brad-Foundstone is the username. So that is provided by our client. So now this identity will be given to the AAA server. The AAA server is going to generate a challenge, and then this challenge will be given to the Buffalo AP, right? Once this access point gets the challenge, it is going to send it over to the client, and that is what we are seeing here. So you can observe it's again EAP packet, it's a request, but this time it's a challenge. And this is the challenge. So challenge is nothing in this case but a set of zeros. It doesn't really matter when you think about it, right? Even if it is a random string, if it is a zero, doesn't really matter, because the response is anyway going to depend on the passphrase, the password of this user, right? So you got this challenge, and now our Netgear, it is generating the response, right? This is the response, and this is the response ID, by the way, right? So if you check this, this says ID, this is the response ID. The response ID is 2 here. And then the challenge was 00000, right? That is the 16 bytes long, which is the length of your MD5 digest. And then this is the response. And now, because this password was good, the AAA server matched this with his own calculation, or derivation of the response, and then the EAP success was issued for this specific device, right? Now, one thing that you should notice here, this is being highlighted in yellow by Wireshark, right? Why? Because Wireshark wants to tell us that this is vulnerable to MITM attacks. If possible, change EAP type, right? It's a security related warning. And this is very important, right? Anyone can actually perform MITM here. That is the first problem. Second problem is, because MD5 challenge is visible to me, anyone who is who's using a monitor mode card in the vicinity, he's able to capture this traffic, and he is able to see this MD5 value. And now he's also able to see the challenge value and the response ID, right? So only thing that he doesn't know is the password. And that is where he can actually run some kind of dictionary attack to find the password. So this is the problem, right? Your response is the MD5 of ID concatenated with the password concatenated with the challenge. So what you can do as an attacker, because you have access to the challenge, you have access to the ID from the packet capture, you can use something like this EAP MD5 pass tool to run a dictionary attack on the captured sample. You can provide it the dictionary file like this, or you can generate a dictionary file, using Crackle or something, and then you can try to run the dictionary attack and recover the password. Right? In this example, you can see that when we ran this, not this example that we discussed. This is the example provided by the tool itself. Similarly, if you don't want to provide the dump, the capture, you can also provide the challenge and the response in the hex format, right? So you can provide that. -E will provide the ID, and then you have the username here, and it will then try to find the password. So this is the problem with using your authentication methods without any protection, that it is vulnerable to MITM. That is first thing. Second thing, it is vulnerable to snooping. Anyone who's checking the Wi-Fi traffic can actually see what is happening here, and then he can try to attack this thing. There are other methods just like EAP MD5. For example, EAP PAP is there, EAP CHAP is there, EAP MS CHAP v2 is there. And as you can tell from the name, MS means Microsoft here. So this is one of the Microsoft's proprietary protocols. CHAP means challenge, right? Challenge handshake, challenge-based authentication handshake. And then similarly, you have PAP here. In case of PAP, it doesn't even perform MD5 or something. It is directly going to send you the username and password in plain text, right? So that is bad. What is the most secure protocol to use? Right now, you can actually use MS CHAP v2, so that is pretty good. But it is not good enough when you use it alone. So you are going to use it in combination of something, and that is what we are coming to now. So what we have observed is if you use these authentication methods directly, there are a lot of problems that can come. And so we need something which will actually protect that. And that something is the encapsulation part. So we observed that when we are using EAP MD5, when we are using EAP PAP, GTC, right? And you will see all of these examples in the lab also. You will do the labs and it will become more clear to you when you will do by hand. But to give you a high-level idea is these authentication methods will use some way to authenticate the other party. Just like in MD5, you were using MD5-based challenges. In EAP CHAP and EAP MS CHAP v2, you are going to use again a challenge-based authentication protocol. But problem is the digests that you are sending, right? It is visible. Anyone, so these are good enough to be used on a LAN network, because when you use them on LAN network, you don't have to actually worry about anyone will be able to see these, right? They won't be until unless you have a vampire tap or something on the LAN cable that is going, right, that is carrying this information. You don't have to worry about it. But when you are dealing with the Wi-Fi or wireless, anyone in the vicinity, right? Even if he is sitting like just like we discussed in the section 1, right? Section 1 of the session 1 of this boot camp, that anyone with a parabolic antenna, he can just sit like half a mile, 1 mile far from your place, and he can still be able to capture your traffic using a high gain directional antenna. So these authentication methods alone won't be able to protect you. And that is where encapsulations will come into play. So what encapsulations will do? These will create the protective tunnels through which you can then pass the authentication method messages. And because all of this will be passed through these tunnels, these will be secured till the time you actually follow the recommended guidelines. So how this is done? So first, let's talk about PEEP, or it stands for Protected EAP actually. EAP again is Extended Authentication Protocol. So in PEEP, you will see PEEP v2, PEEP v0 and PEEP v1 as two variants. So PEEP v0 is used with EAP MS Chap v2. Because MS Chap v2 was protocol from Microsoft, PEEP v2 combination with EAP MS Chap v2, PEEP v0 with the EAP MS Chap v2 is the most popular one. Why? Because it was natively supported on Windows, and we know that Windows is the most popular operating system as of now, right? So it is the most popular one, and it is secure till the time you follow all the guidelines. Then similarly, you will also see some cases where PEEP version 1 will be used with EAP GTC. And you can also mix and match in most cases. So you can actually select which one you want to use as the outer uh, protection, that is the encapsulation part, and which one you want to use for the authentication, that is the internal part, the GTC, the CHAP, the MS CHAP, and MS CHAP v2, right? Uh, PEEP uses server-side certificates for validation of the server, and then for the validation or authentication of the client, these authentication methods will be used. So let's take a look at this. So what we are doing here, right? So this is the PEEP that we are going to discuss now. So let me just turn on my marker. Yeah. Okay. So this is your supplicant, station, client, right? You can use any term that you like. Authenticator means your access point, right? And then authentication server, we know it's the radius or AAA. Again, this part is on wired LAN. This part is on wireless or Wi-Fi or wireless LAN, right? So this is the part that we are more concerned about, right? This one is not so much. So here, when your client or when your station wants to connect to access point, uh, it is going to first discover this, by using the beacon frames, by using the probe request and responses. We have already covered those like gazillion of times, so not mentioning those here. After that, this guy will send a auth, right? That's the auth packet. It will be sent to access point. Access point is going to send a auth to this guy, right? So authentication packets are now exchanged. After that, association request and association response is exchanged between two parties. And after this much, we can then start with the authentication part. We can start the EA pool or extended authentication protocol over LAN, right? So our supplicant or our station now requests to start the EA pool. Access point will ask for its identity, right? The identity will be provided here. Now this identity can be real, it can be fake, it depends, right? And anyway, this identity is just for the sake of it, right? It is not actually going to be used really. So now this identity will be passed to our AAA server by the access point over the LAN, right? And now after that, this guy, the AAA server, will say, okay, EAP PEEP start, right? So instead of saying EAP start, it is now saying EAP PEEP start. And EAP PEEP start will be sent to the client. Now client, which already has support for all of these protocols, it knows what it actually means, right? So now what we are trying to do here is we are trying to set up a secure connection, secure end-to-end connection tunnel between your AAA server and your client. And why we want to do this? Because we want to make sure that whatever we are exchanging in terms of authentication protocol, it is safe from eavesdropping. No one will be able to see it. And it is safe from the MITM attacks, that is man of the middle attacks, right? We don't want anyone to mess with what we are going to exchange now. That's why we want everything in a secure tunnel. And how do you do that? We do it every day. We do it every day with the HTTPS, right? Which is nothing but HTTP over TLS, right? So that is exactly what we are going to use here. We are going to set up a TLS tunnel. Once the tunnel is set up, we can then exchange whatever we like inside the tunnel without worrying about other parties. So for that, this client will actually send the client hello. It will also propose the cipher suites that can be used. This same message will be sent to the AAA server. The AAA server will respond with the server hello. It is going to share the server certificate. It will also choose a cipher suite. Don't worry if you are not able to, if you're not able to understand what the cipher suite is, what a certificate is. We are anyway going to see all of it. So this server certificate is set. Server certificate come here, right? Certificate is given here. This is the TLS certificate. Now we know why the TLS certificate is used, right? We use it every day on HTTPS. The reason why it is used is to validate that the server that we are communicating with is the legitimate one. And how do you do that? You get the certificate here. You have your list of CA certificates. CA means certificate authority. So once you have the list of CA certificates with you, you use those CA certificates. It can be one, it can be multiple, totally depends on your setup. You can use one of these to validate this certificate that is sent by the other party. If it is not valid, you are actually going to see a warning. You are going to see, just like when you are trying to do this with HTTPS, your browsers actually show you a warning, right? Similarly, when you are trying to connect to a network and your client, your supplicant detects that this specific certificate is not valid, it actually shows you a warning. It actually gives you an option to go with it or to reject this, right? And this is very important step because all of the attacks that we are going to discuss depends on this attack, this step here. So now suppose the certificate that is sent by the server is valid. It is, it checks out with the CA certificate. So the client accepts it. Once the certificate is accepted, after that, there are 2, 3 more steps. They exchange some more specification, they exchange some more standard packets. And once all of that is done, a TLS tunnel will be established between the client and the AAA server. Now, the important thing to note here is because this tunnel is end to end, even your access point, right, which is sitting here, is not able to see what we are going to exchange in this tunnel. So it is, that good. It is end to end, from this end to this end. Whatever is inside, no one can actually see. So this was the third phase. Once this tunnel is set up, after that, uh, we go to next phase. In the next phase, what will happen now? Now, everything that is exchanged in this section here, it is inside the TLS tunnel. So no one will be able to snoop on it, right? No one will be able to perform MITM attacks on it. It is totally safe. Till the time your TLS tunnel is safe, and we will talk about it, how to attack it and all. You will then understand where the problems are, what can be done. Now, again, once this tunnel is established, this guy, this AAA server, is going to request for the identity. So it will request for the identity. Once it requests for the identity, this guy, this supplicant or this station is going to provide the real identity now. In some cases, I have seen that the clients, they actually provide real identities, both the cases, because it is just the username. In some cases, I have seen that the client, they actually provide fake identity outside of the TLS tunnel and the real identity inside of the TLS tunnel. So once the identity is provided, now because the username is provided, your AAA server will actually use that username to look up the user. And once the user is found in the records, his password is also retrieved by the AAA server. And then the AAA server is going to create a challenge. And this challenge will be sent to the station. Your station already knows the password, provided that it is the legitimate user. It will take the password, it will take the challenge, it will generate the response. And again, just like in MD5, you had different way of doing it. In MS-CHAP, you have different way of calculating this challenge and response. And you can read more about it in the RFC, right? I have not included the calculation of digest here because it is again, it is some method that you use, uh, not really very important from our perspective. The main thing is that it's a challenge handshake based authentication protocol, right? Uh, so once you have generated the response will be given to the other party, that is the AAA server, and everything is happening in the TLS tunnel. So even our access point is not able to see what is happening. It will just see TLS application data, just like we will be seeing in the Wireshark. So once this response is provided to AAA server, the AAA server is going to check it. And how to check it? Again, it will calculate the response using the information that it has, and it will match its response and the response provided by the station. If it checks out, that means the station is providing the correct password, and we can let it connect. So once that happens, EAP success or MS-CHAP v2 success is sent to the station. And along with that, if you check this blue part, you'll actually see that the key material will be installed on the access point, and this key material is also given to the station. So both parties now have PMK. Not really here. PMK is actually here, right? So not here. So once the PMK is there, what we need to do? Obviously, we need to generate the temporary keys, that is PTK. How do you do that? This is your four-way handshake. And once you do this, you have PTK on both sides. You take TK from it and you use it to encrypt the traffic. So till here, TK, right? And after this traffic is then going to the internet or other places, wherever it wants to go, right? This part is encrypted, this part is not, because it's the wire link. It's not our headache now after this point. So this is what your PEEP V0 and MS-CHAP V2 is. So let me clear this. So guys, any questions till here? Any questions that you want to ask right now? We are also going to do a packet walkthrough of this, so it will become more clear. Okay, cool. So let me go to the packet walkthrough, and then I think some of you might have questions in that case. Okay, let me remove this. Okay, yeah. So you guys should be able to see the Wireshark now. I have opened a packet capture here. So whenever we want to perform analysis of Wi-Fi traffic, it is again advisable. It is not important. It is not something that you have to do, right? You must do. It's not like that. But it is advisable that you start from this place. So you go to wireless, especially if you are not sure what you are looking for, right? So start from here. You go to WLAN traffic, and it is going to show you a complete summary of all the Wi-Fi traffic that you have. And from here, you can actually sort it. So we are going to, now we know that all of these SSIDs are the one with most traffic. And you can also see that the data packets, the beacon packets, and all of the information about these, right? I think we have a question. Oh, okay. You cannot see the pop-up. Okay. Thanks for letting me know. I'll just, okay. Maybe it's because it is only sharing one thing. Okay, let me share my screen. Okay. Okay. All of the screen is shared in this case. Now you should be able to see it. So we go here and we click the WLAN traffic part. Now you should be able to see it. And now I can actually use this part to sort it. We can observe that our example SSID now has uh, the most traffic, right? This is the one that we are behind or after. Okay, yeah, now you guys can see. Okay, yeah. So yeah, here we are. This is the BSSID, right? This is the BSSID here, and then you have other clients. It is also showing that it's the base station. So now what you can do, you can actually apply a filter from here also. So apply a filter, WLAN adder. You can close this, and now we are only seeing traffic from this BSSID, right? This is the example BSSID. Now, one way of clearing the traffic, as you already know, is to ignore all the packets that you don't want to see. Especially take the probe responses and probe requests and beacon frames out. It will remove most of the traffic and not selected. That is the first one. We can also remove these packets. These are the control frames. So, and not selected. And then beacon frame is there. So let's remove that too. Yeah, this is here. And there you go, right? Now you have the remaining packets, but it's okay. We actually need these. So here, another way of filtering this, you can also use BSSID here, but doesn't really matter. This will also work. So now you can observe that there is this probe request that is looking for the specific network. This client was looking for this network. So here your TP link is the client and your D link is the access point. And again, we are only seeing the wireless traffic here. So we will never be able to see what the access point is talking with that AAA server. For that, you have to take a capture on the LAN side and then you will be able to see. So now, first is the authentication packet exchange between client to the access point and access point to the client. Then comes the association request and response, and then this is the EA poll start. From this is, you can see here, it's a data packet, as you can notice, right? Inside the data packet, you have 801.x authentication packet, and this is the type, that is start. So once this packet is sent, you will actually see that the access point is now requesting for the identity, right? So identity is requested. If you move down here, you will actually see the same frame, which looks like to be retransmitted. And here, you will actually see that a packet is coming from the access point. So here, sometimes what happens, okay, so you have a question, you have to ask the question in the Discord. Just put it in the Discord and I can read it there. So here, the first time when this client responded with the identity, we actually lost that packet from the capture. So that's another thing about the wireless network. Sometimes you lose packets, right? So we are not able to capture that. Now, or it is also possible that in some cases, it has transmitted it, but not even the access point and not even, our capturing setup was able to see it. So this happens sometime. Now, what you are seeing here is access point is actually asking us to start PEEP. So it is request to start protected EAP or EAP PEEP. And after this, you will actually see the first client hello that is coming from the client. And you will have observed that we have EAP packet here. Inside the EAP packet, you have EAP TLS flag set, right? So EAP TLS flag is this here, where start is set to false, right? So it is not EAP TLS that we are using. We are using PEEP. So this is the client hello. If you open this packet from here, you will actually see all the content that is there. It is sending a lot of content. Here, you will be able to see the cipher suites. What are the cipher suites? These are the lists of the crypto primitives that you want to use to secure this TLS connection. So as you can observe here, take example of the first one. TLS is just something that they are adding to this cipher suite name. Then you have ECDHE. ECDHE stands for elliptic curve Diffie-Hellman exchange. We are going to talk about this when we are going to cover WPA3 because it is essential there. So this thing is used to share or to generate the shared secrets over unsecured media. Then you have ECDSA. This is the signing algorithm that we will use. And then you have AES 256 GCM mode. AES 256, as you know, AES is the encryption algo, symmetric encryption algo. 256 is the key length for our AES, and GCM or the Glock counter mode is the mode in which AES is being used here. And then SHA 384 is the one that we are going to use for the integrity and for the HMAX that we are going to use, right? So these are the options that this client is providing to the server that, okay, to use an encrypted channel, we can use any one of these. The selection choice resides with the second party here, which is the server, right? And similarly, you have the compression methods, the EC format, the supported group, all of this is related to your crypto. So you can actually explore it. I'm going to share this PCAP with you so you can actually explore it. So these are the supported groups for that, right? You can see all the information that is here. So in response to your client hello, so this packet, you can ignore it. It is the same packet that actually came here. You will actually see this server hello packet. So server hello is the response to your client hello. If you open this up, you will actually see it's very confusing here. So you will actually see this is the server hello. If you open the server hello, you will actually find the cipher suite that is selected by the server. So server actually went with this one. This is using ECDHA. It is using RSA for signing, AES 256 GCM for encryption, and SHA 384 for integrity. So this is the first part. Then it is also sending its own certificate. So you can actually see certificate here, right? This is the complete certificate. You can even open it, and you can even see that who has signed it and all of that information, right? So you can dig deep into this, and the more deeper you will go, you will actually find more things. So certificate is given. Then the server key exchange packet is there. And similarly, the server parameters are there. All of this is done. And once it is provided, now they are ready to form a tunnel, right? But after exchanging this one more packet here. So now what you will actually observe here is once all of these setup packets are exchanged for TLS, you are able to see TLS v1.2 packets here, but you are not obviously able to see what is inside it. These are the data packets now. These are the authentication packets that are going inside the tunnel. And because these are inside the tunnels, these are encrypted with TLS, we are not able to see these, right? So it is telling us that the application data protocol is EAP, but we are not able to make sense out of it. So these will look totally gibberish because these are encrypted. And now inside this, MS chap v2 is actually going, right? So all of this application data is there. And after that, in the response, okay, so this is again this packet here, response packet. So if you actually open this, it will show you some data. And this actually means here that your authentication was actually failed in this case. And after that, this access point is now disconnecting from uh, the client. That is what is happening here, right? That's why you are seeing the dissociate and deauthentication packets, because they are actually disconnecting from each other. So this is the packet walkthrough for your EAP. So let's go back to slides and let me check for any questions that you might have. Okay, so there are no questions. If you have questions, please feel free to put them here in the Discord. So guys, it is time for your 5 minutes break. I think we have already pushed it by 10 minutes, but let's take that break, and you can grab water or something, and we can again meet here after 5 minutes, and we can continue with the remaining part. Welcome back, guys. So let's start with the remaining part. Any questions till here? Any questions in the walkthrough? If something is not clear, just let me know. Otherwise, I'm going to give these PCAPs and the slides to you like every time. So you guys can go through it, and if something is not clear, you can ask on Discord. Totally up to you. So now let's understand what's the problem here. The problem is on a server-side certificate, all the dependence is there, right? Because your authentication protocols that were there, right? They were working. So just a minute. Yeah. So how things are happening now, right? You have to understand this. We have our client here. Our client, okay. Yeah, this is our client. And then we have our access point here. And this is our AAA server. We were using authentication methods first to authenticate with the AAA server, right? This part is here, obviously, on wireless. And this one is here on wired. Now, the problem in this approach is whenever we were trying to communicate the packets for the authentication protocol, right? It was not working. It was working, but the packets that were going between the access point and the client, these packets were visible, right? For the authentication protocol. That is your EAP, PAP, EAP CHAP, EAP MD5. So to protect against that, what we did, we actually created a protective tunnel. That is our TLS tunnel. So that whatever is going inside this TLS tunnel, it is not visible to outside people. And then they won't be able to see what kind of authentication protocol we are using, and they cannot attack it. However, when we are forming this TLS tunnel, right, to validate the AAA server, we are actually relying on the server certificate. So here, all the security of this scheme, right? So if we talk about the domino effect, right, everything is dependent on the TLS tunnel, and the TLS tunnel depends on the certificate. So if the user is accepting any invalid certificate, or if the client device that we are using, if it is for some reason not prompting for it, then all of the security that we have put into this will be failed, right? Because everything is relying on the TLS tunnel. Your authentication protocols, they are relying on the TLS tunnel for their security, and your TLS tunnel is relying on the fact that this server certificate is valid and we are communicating with the correct AAA. If the certificate is issued by the fake party, the tunnel will be created with the fake party, and because the fake party is creating the tunnel with itself, it will be able to see all the authentication protocol packets that we are passing, and then it can attack the authentication protocol, right, to recover your username and password. Once the username and passwords are recovered, it can then access the network. So that's the problem, and that is how we are going to actually attack our enterprise networks. So how we are going to do this? Obviously, we need to set up a honeypot, right? How we can do that? We already have a Wi-Fi card with us, right? Monitor mode card. So we can use hostapd to create a honeypot, right? Because it's an EAP, right? So we also need AAA server. So this AAA server can be deployed using your free radius. You can have a free radius. And this is now advertising its SSID here. A client will come, client will try to connect to this. And because if it is using EAP, right, this message will be passed to the free radius. The free radius is again, we have tampered with it here in some way. It is going to communicate with this guy. And here the free radius is going to send its own certificate. Now, why this client connected to this SSID? Because we have stolen this name, this SSID, from a legitimate SSID that is known to client. So for example, suppose the SSID of client's corporate network is say evil cop EAP, right? Just an example. So what we are going to do, we are going to create a SSID with same name, right? With same SSID, we are going to create this network. And when this guy will connect to it, it will start looking for the radius server. So in that place, instead of having the right AAA server or the legitimate AAA server, we have our free radius that we have created, right? So this guy is going to provide a certificate here. Now, because this certificate is not the valid certificate, right? It is not signed by the proper CA, which is installed with this guy. So this client is going to see a warning. Now, if the client accepts this certificate without paying heed to this warning, all the setup is now going to fail, because then the TLS tunnel will be formed with our fake setup. And then this guy is going to reveal its challenge and response. A challenge is given by us, but the response is the main part. Response is the one that contains the password information, right? So when the response will be revealed to the evil setup that is controlled by us, we can then attack it and recover the password. So that is the problem with this setup. Everything relies on the certificate part, and that is where your client is going to make mistake, and that is what we are going to leverage, right? So set up a honeypot, then make the client connect to this honeypot, and then use your fake AAA server to connect with it. Now we can connect a passive, we can create a passive honeypot, or we can create an active honeypot. It totally depends on how we want to do this. And what is the difference here? So when we talk about a passive honeypot, right? So suppose we are creating a passive honeypot. Passive honeypot is a network in which you have defined the SSID and the security scheme, right? For this example, we have defined the enterprise security scheme, and we are using, say, PEEP with MS-CHAP v2, right? That is what we are doing. So in case of passive honeypot, it is not going to do any active activity. It is just going to broadcast its network. The client comes. If the client automatically connects to this guy, well and good. If it doesn't, the honeypot is not going to do anything. Wherever, in case of our active honeypot, so what we will do, again, we will create a SSID with enterprise scheme. But in this case, what we can do when a client comes, right, if it is not connecting to this guy, we can use karma attacks. So what are karma attacks here? Suppose this client, we have created SSID, say ABC underscore net. This is our SSID, okay? And it is using, PEEP, MS-CHAP v2, right? Now this guy, he is not looking for this specific network, but it is looking for, say, XYZ underscore net. So what we do in karma attacks is our honeypot, our active honeypot, is actually also listening for all the probe requests that are coming from the client. So as soon as this guy is going to see this, right, it is going to send a probe response saying that, okay, I have xyz.net, which is not the case, right? But that is what karma attacks do. When this guy will see this response, it will try to connect to this BSSID. That is the karma attack. That is one way of actively trying to lure the user. Another way, obviously, is by using the deauthentication attacks, right? You have your access point, fake access point that you have created. The user is connected to some valid access point. So what you can use, you can actually send a deauthentication packet, spoofed deauthentication packet. This guy will disconnect from here. Make sure it is disconnected from here and it is connected to your network, which is using the same SSID as of this SSID, right? So that is your deauthentication attack. So your active honeypots will use deauthentication and karma, whereas your passive honeypots are not going to do that. They are just going to sit and wait for the client to connect, right? So this is going to be the scenario. Your fake access point and fake radios is going to be in this combo, and then the target client will come, and if it connects, then you can try to attack it. Now, what are the tools of trade for this? Uh, People used to use these tools, the combination of hostpd and free radius, for quite some years. But the problem was that you have to set up both of these, and free radius, it is not very user friendly when you try to set it up, especially when you are doing this for this kind of purpose. You are trying to set up it on the same server or on the same laptop, right? So all of those configuration problems and issues will then come. It will not get installed on Windows and all of that. uh, so what people did, they actually came up with the hostpd WPE. So this was a derivative of hostpd, which was actually using a patch. So this patch actually used to give this power to also work as a radius server. So this one is also very old now, but it will still work. Again, not very easy to use. Then came the hostpd mana. So hostpd mana is this tool developed by SensePost. So this is really good to use. Again, it is a extension of hostpd, that is the open source software. So what they have done, they have created a fork out of hostpd, and in that fork they have added a lot of other capabilities, like it can work as a radius server. It can run karma attacks, right? All of that. There are other things also that hostpd mana can do, and we will see those in the upcoming sessions. Then there is this one another tool that is called EPHammer. EPHammer is the latest one, and it is very easy to use. It has so many capabilities. uh, you just need one line of operation to run it. It is not going to ask you for a lot of configurations. In case of hostpd mana, you have to write the configuration file, you have to provide the configuration file, right? So EPHammer actually takes care of all of it. And this progression, right, this progression of these tools also shows us how far we have came as a community. So we are improving our tools, we are making these attacks very easy to conduct, right? Good time to be in infosec. So now let's take a look at how we can crack the PEEP MSCHAP v2 uh, using hostpd mana. So this lab is available on Attack Defense, as you know, right? Most of labs are. So in this case, we are going to use hostpd mana to create a WPA2 enterprise Wi-Fi network, and then we are going to use it to steal the credentials from the user. The setup that is being used is the PEEP MSCHAP v2 security setting, right? So we have uh, checked the objective. Now we can move to the lab. And we are inside the lab. First thing that we do, we check for all the interfaces, all the Wi-Fi interfaces that are connected to our machine. In this case, as you can observe, there are two interfaces. Uh, and we also have some certificates kept here. This folder contains some certificates, CA certificate, server key, all of that is there. And then you also have this dictionary file. Now what we are doing is we are actually putting WLAN 0 into monitor mode, so we can run aerodump on it and we can inspect what kind of networks are in the vicinity. Aerodump is now showing us all the networks that it is able to see. Now in this case, right, so we wanted to make this lab easy. So that's why there is no network in this. Only one client is there, which is actually looking for a network. Which network it is looking for? It is looking for amaze underscore LLC network. And we know from the challenge description that this network actually uses PEEP MSCHAP v2. So this is a client only attack, right? So you're only going to attack clients when it comes to enterprise attacks. You are not going to attack access points. So you have a client here. Now what you can do is you can create a honeypot, and then you can make this client connect to your honeypot, and then you can try to steal its credentials. So if we check the search directory, you will actually see 4 files. First file is the CA certificate. Second file is the DH parameter file. It is used by the Diffie-Hellman exchange, right? Don't worry about it if you don't know. We are anyway going to cover it in detail in next session. Third file is the server key, and the fourth file is the corresponding server certificate, right? So whenever you want to, create your TLS connections, whenever you want to make sure that your server is supporting HTTPS or something, you need these certificates. So server key and server certificate, it's the combination that you will need, because if you don't have the key, you cannot really use this. So we have provided these to you here in this case. If these are not given, you can always use OpenSSL to generate these. I'll post. I'm very sure that most of you guys are already familiar with the TLS certificates. If you are not, don't worry. I'll actually post some resources in the resource channel, which will talk about what these are, how these are used, and how you can generate these using OpenSSL. So we have all the certificates here. Now we are going to generate the configuration file. So we are naming it peep.conf. We are directly pasting the configuration here. So our configuration is going to use WLAN 1. This is the host APD configuration, but it is a little bit modified. It has extra parameters because we are going to use this configuration for host APD MANA, which they have created as additional version of host APD, which has more capabilities for us attackers. So we are going to use WLAN 1. The SSID is amaze_LLC. The channel is 6. It doesn't really matter what channel number you use. You can use any one of the channels, because there is no other network there. So any channel you operate on, the client is going to come and latch on to you till the time you have a proper SSID. Then you have the hardware mode, the WPA key management, the pairwise key management. Here you can see in the key management, we are putting WPA EAP, not the PSK, right? Because it's the enterprise network that we want to create. Here we are using both TKIP and CCMP, which means this will be your WPA2 enterprise network. We are enabling IEEE 8021X, right? Which means the radius server is enabled, and then EAP server is also enabled. We are passing this information to hostapd MANA, so it can actually turn its EAP server on. That is inbuilt in this. Then we will provide it EAP user file. This is the file that we have to create. After that, we are providing the CA certificate, the server certificate, the private key that is corresponding to this server certificate, and then the private password. So our private key is not protected by any passphrase. It is a recommended practice that you protect your private keys with a password. If you have done that, then you have to mention the password here. In our case, it is blank. So that's why we are not providing anything here. Then we are providing the DH file, the DH parameter file that is given, right? And then we are enabling the MANA WPE. And the last line means we are going to return EAP success all the time. So we save this hostapd MANA configuration file. And after saving this, now we need to create the EAP user file. So this is the hostapd.eap user file. We will paste this thing here. And what this is actually doing is it is directing hostapd MANA that doesn't really matter which security scheme the client is using, we are going to engage with it. So if the client is using PEEP MSCHAP v2, we are going to engage with that. If it is using EAP MD5, we are going to support that. If it is using TTLS MSCHAP v2, we are also going to allow it for that. That is what this means. So we save this, and now we are ready to launch our honeypot. This is the configuration file, the peep.conf, right? This is the file that we just created, the eep user file. So everything is ready now, and we can use hostpd mana command to run hostpd mana. We can pass it the configuration file, and as you can observe, the honeypot is in progress. It is operating now, and we can also see the same, in our aerodump. And what you can see now is the client that was roaming around and looking for amaze underscore LLC, now connected to this. As you can observe, the username here, the identity, right? This is the identity that is revealed in phase 0. So this is the first time when your access point is asking for the identity. That is the phase 0, right? It is the external part. So it has revealed its name as Sean. So you can see that. After that, the TLS tunnel is formed, and inside the TLS tunnel, you can then again see the identity. Again, it is Sean, and then you can see the MS Chap V2 challenge and response. So your hostpd mana is actually parsing everything and showing you in a very user-friendly way, where you can just copy this part and run it, and asleep will then run the cracking attack on this challenge and response. Similarly, it is also giving us the format compatible to JTR and the hashcat. So we can, run this, and it will automatically start the dictionary attack. I think we have a question. What message when the user is checking the certificate? Okay. So in this case, in the lab, we have emulated the user. So user always accepts the certificate. But what I will do, I'll actually post a screenshot of that message so that you can see it, right? I don't have that right away with me. Uh, I think that is in the slides somewhere. I'll show you. If it is not there, I'll just post, a example for you to see. So just a minute. Wi-Fi certificate error. If you search EEP, it will actually show you that. Okay, images. Yeah, I think I have found it. So what I'll do, I'll actually find a good image of it, and I'll share it with you. Currently, it's not really a good example that I'm able to find on the fly. So don't worry about it. I'll share the message with you so that it's clear to you how it actually looks. You have seen it. I'm very sure that you have already seen it. You are just not able to relate it. We have all seen it in sometimes. So now here we have the contents of your MS Chap V2 authentication scheme, and how it is possible, because as an attacker, we were posing as the access point as well as the radius. And when the client wanted to connect to us, we actually gave the certificate that you can see in this configuration file here, right? The server.pem was used for this. And because we have the corresponding key, we are actually able to see everything, because this tunnel is created with us. So the other endpoint is with attacker, and attacker in this case is us, right? So that's why we are able to see this. And because the client, he accepted our certificate, all of this security of encapsulation actually uh, was bypassed. So once you have the MS Chap V2 hashes with us, the challenge responses with us, we can use asleep or hashcat or JTR, whatever is installed on the machine, and we can run a dictionary attack on it. So that is what we are doing here. We'll paste the asleep part that we had copied from above, and then we are defining the word file. And there you go. Because the word file, the password file is very small here, so we were able to perform the dictionary attack, and this is the password for this user. So now you have the username, that is Sean, and you also have the password. And what you can do with this, you can use these credentials to connect to the real password. sorry, the real network, not the real password, the real network. And then you can break into the enterprise network, right? Once you have connected, you can get the IP address, and then you can perform your recon attacks and all of that. We have a question, I think. Will the client receive a message to accept your fake certificate? Yes, 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 yes. So client will actually see a message that this certificate is not actually, the client or the device was not actually able to validate this certificate with the CA certificates that it has. So do you want to continue or not? Just like in terms of HTTPS messages, right? Whenever you are trying to visit a site which is using a self-signed certificate, you actually see this message that do you want to continue or not, right? This doesn't look right. So similarly, you actually get a pop-up on your client device. Uh, and if you ignore that, if you choose to go through this, then this attack is possible. If the client does not accept that fake certificate, this attack won't work, and then you won't be able to attack enterprise networks, because the TLS tunnel that is created by the PEEP or the TTLS is a very strong thing. You cannot actually break this, right? And if you cannot break it, you cannot touch the authentication methods. If you cannot touch that, you won't be able to recover any credentials. So this was your PEEP MS Chap V2. Okay, we have, could you use Let's Encrypt certificate on HostGPT? Yes, yes, you can. You can use Let's Encrypt also. So yeah, that is one another issue that I was going to discuss later, but you have already pointed it out. So sometimes what people do, right? They will use something like this. They will use Let's Encrypt certificate on their AAA server. Now, problem with that is, to validate this, you will actually ask all of the client devices to add a CA certificate that can actually validate Let's Encrypt, right? So that is all good, right? You will issue the certificate, the other guy will then validate it. But the problem is, if I can generate, anyone can generate a certificate for a legitimate domain or for a legitimate server from the Let's Encrypt service, right? So I can also generate it. And then your CA certificate that your clients are using, right? They will also validate my certificate because it is also coming from the Let's Encrypt. So then it is not going to show you the error messages, right? So for this, what people do, in enterprises, especially in the big enterprises, they have their own CA certificates, and they will use their own CA key to sign these self-created certificates, so that only their CA certificate can issue these, their CA certificate and key can issue such certificates, and only they can validate it. So if someone is using that approach, obviously there is an overhead. They have to first install their CA certificate on all the client devices, but most of the enterprises, they actually do this. Once you have installed that, even if I have a certificate issued by Let's Encrypt or Visa or VeriSign, or whoever is the certificate authority, that won't work, right? So that is more foolproof. Having your own CA in this case is more foolproof than using a Let's Encrypt or something, because the use case is totally different from what you have in terms of your browser, and what you have here in this case. So going down Let's Encrypt's route might not be the best thing to do. Now here, there is a little assignment for you. So when you will do the lab, it will become clear to you. You have to understand why PEEP GTC is weaker than the PEEP MS Chap V2. So that's the question for you. Once you cover the PEEP MS Chap V2 lab, once you cover the PEEP GTC lab, it will become very clear automatically. So now let's talk about EAP TTLS. TTLS stands for Tunneled Transport Layer Security. It is another way of encapsulating things. In this, again, it is very similar to PEEP actually. In this one, again, your server is authenticated with certificate. So server is going to provide a certificate to the client, and if the client is able to validate it, if the client accepts it, then the TLS tunnel will be formed, and then inside the TLS tunnel, uh, your traffic, your authentication traffic will go, right? But in TTLS, there is also an option to validate the client by using the certificate, right? So an extra layer of security. But again, validating the client using a certificate actually becomes a headache because it's a PKI problem. Then it's a public key infrastructure problem. How you are going to distribute all the certificates, how you are going to manage it for all the clients, right? All of those problems come. And that is the reason why EAP TLS, that is another variant, that is another way of providing encapsulation, is not used. EAP TLS is very secure. It is very safe in that both client and the server can, they will use certificates to authenticate each other. And because they use certificates, then it becomes very difficult to actually do something about it. But the problem with that is you don't want to manage separate certificates for every client, right? Then you have to deal with the revocation, the sharing, right? A lot of the other issues are there. So that's why EAP TLS is not very popular, even when EAP TLS is the most secure one. So in EAP TLS, okay. So we have a question. So don't use Let's Encrypt in an enterprise environment. Install the CA role. But as an attacker, threat actor, we can use Let's Encrypt to get the user trust the certificate or still no. So see, you have to understand here in this case, right? Uh, let me draw here. So I think it will become more clear to understand. So there are two things, right? Uh, Whenever we are talking about this, first thing is your client, right? This is your client. It is your phone or your laptop, right? Second thing that we are talking about here is the AAA, that is the radius, right? Now suppose both of these, they belong to same enterprise. This is a user device. The user belongs to enterprise, same company, and that same company is also governing AAA radius, right? This server, and the network belongs to this enterprise, and this guy wants to connect his device to this network that is there. So the way they validate is, now here are two things to validate. First thing, the enterprise want to validate that this user is the legitimate user, and for this purpose credentials are used, right? Now that's the first thing. Now the problem is your user, right? You have a way to validate the user, but your user does not have any way to validate if it is talking to the real infra. If I have created a honeypot, right? If I have hosted my own fake radius, there need to be a way for the client to validate the radius before it actually reveals its credentials, right? And for that, we are using server certificate. So this guy, this AAA server, is going to give its server certificate to this guy. This is the server certificate, right? That resides on this guy. It also has the key for this server certificate. Now, validation of these server certificates, right? How to do that? So there are two ways. So, you were talking about the first way, that is using the Let's Encrypt CA. So suppose we have generated this server certificate and key using Let's Encrypt, right? Now, thing is, if it is generated or signed by the CA of Let's Encrypt, if you have installed a CA certificate of Let's Encrypt, right? When you will send this server certificate, it will be validated, right? It should be, right? Because it is signed by the same CA. Now the problem is, if I create a honeypot here, and if I also generate a certificate from Let's Encrypt, and if I give this certificate to this guy, again it is going to validate it with the CA certificate of Let's Encrypt. So it is going to pass, right? And we don't want this. We don't want this, right? So what we should do, and what most of the bigger enterprises do, they actually create their own CA certificate, which will always remain with them. No external entity can actually get this CA certificate from them. No one can get their certificates signed by this CA certificate. So they will say that only use this CA certificate when you are validating the certificates, right? So when a certificate that is signed by them and is hosted on their AAA comes, it will be validated. But if I, as an external user, is providing any other certificate, it will be failed, right? So this is the scenario that we want. I think it is clear now. Is it? Is there any doubt? No, it's totally okay. Means you are supposed to ask questions. That's totally okay. That's the main benefit of the boot camp, right? If you don't ask questions, then it's just like a recorded lecture then. So that's totally fine. If it is not clear, I can always again understand. No worries about that. So this is your EPTLS, right? In EPTLS, you have an option to validate the client also using the certificate. But most people don't use this option. So the third thing that I was talking about, right? I was talking about another encapsulation method, or it is also an authentication method in itself. Actually, it's not an encapsulation method, but also authentication method. That is EPTLS. In EPTLS, what you do, your client as well as your server, they both uses certificates. They don't use any kind of credentials, only certificates. Now certificates are difficult to forge, they are difficult to steal and all of those. Even if you steal the certificate, you cannot steal the key, right? Because key, uh, if you follow the perfect guidelines, key should never leave the device. This is how it is. uh, so you will generate the certificate here, you will get it signed, and then you will use it, but key should not leave this machine. But the thing is, to manage the certificates for so many entities, it actually becomes a headache. So for example, suppose there are like 1,000 or 10,000 people. Uh, Now, if you have to manage a certificate for all of these, right, it becomes a problem. And that's why even when EPTLS is the most secure one, you will see that it is not used a lot. People, generally they will go for the PEEP or the TTLS because there is low overhead to maintain and operate these things. And these are secure enough if your user is, if he is not making any mistakes, like he's not accepting these certificates from other parties. So your EPTLS process is, almost the same as the EPP. If you compare all the phases, you will actually see it's the same thing, exactly same. You will actually first, exchange those Wi-Fi WLAN related packets, like your authentication association packets. You will then start the EA pool. After that, you will give the identity. After that, the TLS tunnel will be established. Inside the TLS tunnel, you will actually pass your MS CHAP v2 or whichever protocol you're using for the authentication. Uh, and after that, once the PMK is shared to both parties, again the four-way handshake will be done, and you're good to go, right? So this part here is the EPTLS, this part is the EPEEP, and you can see that the striking similarity is there. There are very less differences between PEEP and TTLS, and what are those? A PEEP TTLS actually gives you an option to use client-side certificate, that is one. PEEP TTLS actually supports PAP as authentication method. So EPAP is a specific authentication method, just like EPMD5. But in this one, you are passing the password clearly. You don't even use any digest and all. And why this is important now, right? Why a protocol which is actually sending the password in plain text is important from this perspective. So thing is, there are a lot of legacy equipments that are still in use, legacy Wi-Fi equipment. Like if you talk about big stores, right, big supply chain stores, in that they have these scanners, Wi-Fi scanners, right? So some of these devices, they are so old, means they are very simple devices, they work, and you cannot just replace those for whole of the supply chain or all of your warehouses, right? Now these devices, these are old and they don't support the newest standards. So a lot of these devices will actually support, PAP or something like that. So that is where your EAP TTLS is also used. So if you want to support an older device which only uses something like EAP PAP, you can use EAP TTLS. That is another differentiator. Apart from this, inside the TLS tunnel, right? In your EAP PEEP, there is this. So this is nothing but the way packets are packed when they are exchanged between the AAA server and the client inside the tunnel. So that is the difference that we have described here. When we are talking about the EAP PEEP, it is a wrapper that is carrying the EAP. Whereas when we talk about TTLS, it is the wrapper around the TLVs. TLV is the type length values. Uh, it is a way to pack the packets, right? It is the way to pack the messages in a variable way. So that's the only difference, but it doesn't really actually make any difference to the user. The security is same, the features are almost same, right? So you can actually go with any one of these two, almost same. So in this example, we will actually see how to crack TTLS PAP, or how to steal the credentials for TTLS PAP using our EAP hammer. So this is the scenario. In this, we have to deploy a evil twin using EAP hammer. And which network we have to target? The SSID is Royal Bank, and the security is WPA2 Enterprise. So what we will do, first we will create an evil twin, then we will force the client to join the evil twin. And when that happens, it will actually reveal the user credentials. Why? Because again, we are assuming that even when the certificate is presented to the client is going to accept it. That is the main thing. That is the main dependency of your enterprise attacks. If the client is clever enough to not accept it, your enterprise attacks won't work. So that is our assumptions in this case. And if you read about these red team stories, you will actually find that when you are targeting a user base of 100, 200, 500, and 1,000 people, one of the guy is going to fall for it. That is what I have always seen. So first of all, we are listing the devices that are attached to it, the Wi-Fi interfaces. We have WLAN 0, we have WLAN 1. Then we are going to run aerodump ng on WLAN 0 to get a lay of land. If it doesn't work like this, then you have to set the monitor mode for this network device. So we are now setting it in monitor mode. On some machines, it will actually work. It will directly work. In some cases, it won't. So you have to set the monitor mode in that case. So we have set that. You can see it's in monitor mode now. And now we are running aerodump on it. So we can observe that Royal Bank SSID is available on channel 6. And currently we were jumping channels. So that's why we were not able to capture the client. But if we set the channel to 6, and that is what we will do, we will also be able to see the client. So there you go. You can see the channel is fixed to 6. And there you go. This is the client MAC. It is connected to this guy. And now we are opening another tab because we also want to create our own honeypot, right? So if we check the listing now, we can actually see that on channel 6, our monitor mode interface is working. It is the one that is aerodump is using. So now what we will do, we have EAP hammer kept here on the desktop. So we switched into its directory, and now we can run EAP hammer binary with the configuration that we want to use. So I'm directly pasting it here. EAP hammer is the binary. -I is to define the interface. We are going to use WLAN 1 because WLAN 0 is already in use. We are putting it in channel 6. You can put it in channel 6, channel 3, channel 4, totally up to you. Then the authentication is WPA Enterprise, that is WPA EAP. We are defining that. The ESSID is Royal Bank, and we want to capture and show the credentials. So with that, just press enter, and it will automatically run hostpd and all of the things in the backend. And now your honeypot is ready. But as you can observe, the client, because it is already connected to the real SSID, right? It is not going to come. And you can also observe this is the fake one that we have just created. You can tell this from the beacon count, right? Because this beacon count is more, which means this one was here for longer period. Uh, and then this is the BSS ID of our fake honeypot where we want this guy to connect. Now it is not going to switch it unless we kick it, right? So we are going to do that. We are going to open another tab, and from that tab, we are going to use air replay to perform deauthentication flood. So air replay ng is used for this purpose. We need the BSS ID. So here, this -0 means we are going to perform deauthentication attack. We are going to send 100 frames. Not really necessary all the time. You can just use 10 in some cases. It's a lab, I'm using 100. You can use less also. -A is to define the BSS ID of the target one. So it's the target network. Then we are directly using WLAN 0. WLAN 0 is on channel 6. That's why it is directly working. If it is not on channel 6, then it won't work. Also, here in this case, this command will disconnect all the clients that are connected to this specific BSS ID. But in this case, there is only one client. That's why we are not caring about it. But if you are dealing with a real world scenario, right? If there are like 10 or 15 clients connected to this BSS ID, don't use this. Also define the client MAC here by using a -C option. After that, define the client that you want to disconnect. So in this manner, you will not disrupt all of the other clients. So once you do that, after that, you can just run it, and it is going to send the deauthentication packets. Sometimes this problem comes. So if something like this happens with you, just use the ignore -1 and it will work. So there we go. And as you can observe, it is sending the deauthentication packets. Now what this deauthentication packet will do, it is going to kick it from the real one, and it is then it is going to try to connect again, but it is getting the deauthentication packets continuously from this BSS ID. So what it will do in that case, it will latch to another BSS ID with same SSID, which is our honeypot here. And as you can observe, it is already connected to our honeypot. And when you will go back to the tab where you started it, you will actually observe that this client connected. It was using EAP TTLS PAP. This guy actually accepted our certificate. And after that, inside the tunnel, it actually revealed us the authentication packets. And as you can observe in TTLS PAP, it actually passes the plain text password. So we are able to see the password, we are able to see the username, and then we can use this to connect to the real network if we like to. So this is how your TTLS PAP cracking will work with your EAP hammer. How to connect to it, all of that, we are anyway going to cover in the labs. So you will actually learn how to do this. Another assignment that is there is to understand why TTLS PAP is weaker than TTLS MS-CHAP v2. I think you have already seen the answer for this. In MS-CHAP v2, you will actually see the challenge and response. So if you don't have a good dictionary file, or if you don't have the correct password in the dictionary file, you won't be able to recover the password, right? However, in TTLS PAP, anyway, you are able to see the password because it is in the plain text. That's why your TTLS PAP is going to be a weaker option than the TTLS MS-CHAP v2. So I answered this for you. Anyway, it's very clear anyway. So we have already discussed about karma attacks. What are the karma attacks? Karma attacks are when your access point replies to the probe requests sent by the probing clients, to lure them. So we have these two labs on it. You can play these, you can see how it works, and it will give you more clarity. Uh, and this karma attacks, it actually rely on the active probing. Your active probing uh, means your client is actually sending the probe requests out. And there is also a privacy issue of this thing, because when you are sending the probe requests out, right? If someone is running aerodump or something on in the vicinity, he can actually create this PNL for you. This PNL means preferred network list. So these are the probes that this specific client is sending, right? This is the MAC of the client. And if these SSIDs are named in such a way, they can actually reveal some information also. So for example, here, right, suppose this RoxCorp, maybe the RoxCorp is the company, and this name is actually telling us that the owner of this device actually works here, or he has visited here because it's the guest, right? RoxCorp guest. Similarly, his home SSID is home sweet home, right? Uh, and we can then, if it is very distinct, we can actually use something like Wiggle. So I'm not sure if you know about Wiggle. Wiggle is your this thing here. So it is actually a database of your SSID names with the locations. So you can actually search for SSIDs using this database. You can feel free to play around with this, and it will try to find if the SSID is very unique, it will find this in its database, and you will be able to see where it is, right? So information leakage, right? You can see all of these are actually uh, the SSIDs in the database, right? So you can run queries on it. You can try to find a specific SSID by writing it here, and then in this way, if your SSID name is very unique, it will actually give you a good hits, and you will be able to find where this guy actually lives if it is his home SSID. So similarly, there are other privacy issues also of active probing. Active probing, when the probes are coming, right? So if you can see all the probes, and if you can see these probes over a large area, you can actually track a specific user, right? If the MAC is not changing, if your phone Wi-Fi MAC is same, uh, and you are sending these probe requests, right? Just like this one, for all probes you are using this MAC. So we know that this guy is actually sending all of these. Now, suppose a scenario where we are talking about maybe a company campus, or maybe we are talking about a city, right? Suppose we are talking about a city, right? Uh, and what I do, so suppose here is your office, here is your home, and then these are all the roads that you can take, right? And then here are the buildings, the cafe and market and all, right? So suppose you go out from here, you are going to your home, and now your phone is actually probing for a network. So what I can do, I can deploy my sensors here, 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 and here. And when you will pass these, because your phone is actively probing, and if your MAC is not changing, this system will see that, okay, at this point of time, with the timestamp, right? At this point of time, it will know that you passed this specific area. And because I have deployed this sensor here, I also know its lat and long location, right? The latitude and longitude of this, or the GPS coordinates, you can say. So what I can do, if I have enough sensors here, I can actually plot the path that you are taking, and which places you are going through, and how much time you are spending there, right? So all of this I can tell if that is the case. And that is what people have done in the past. So I have added this link here. This talks about Creepy Doll. Creepy Doll was an experiment like this only. So they used the MAC address of the phone to track a user through the city, right? So you can do something like this. Similarly, you can also use the MAC address to check when a specific user is coming near your house, or a specific user is entering a specific place, right? Without the user even connecting to the Wi-Fi. That's the main part, right? Because it is probing. Now, due to these problems, right, due to these privacy issues of active probing, what people or what companies actually did, they started with MAC randomizations. Apple started this trend. First of all, this MAC randomization thing came with Apple. So what happens is when your phone is probing, at that time it is going to use fake Macs. That is what it does. So you cannot track it, around the city then, because it is changing Macs. It is not using its real Mac. It will only use its real Mac when it will really connect to a network. So till the time your device is not connecting to the networks, the Mac is secured. No one can actually track you on the basis of Mac. But suppose if you have connected to airport Wi-Fi or something, or some secured network whose password is now leaked to the attacker, or he has figured it out, he can then create his honeypots at these places, and your phone will then start connecting to these. And because when it connects, it uses its real Mac, right? So by that means people can still track you, but it is not as easy as it was before the Mac randomization, right? So that is one observation. If you want to read more on it, now Android also supports Wi-Fi MAC randomization. You can actually read these, or you can even search. You will find a lot of articles on these, and people trying to break and circumvent this. Uh, so assignment questions, we have these two questions. How we can perform MITM on EAP MD5? That's the first question. You have already studied EAP MD5 now. So by now you know why we can perform MITM and how we can perform. That is something that you have to think of. When we talk about Wi-Fi enterprise networks, there is this attack called Hole 196 attack. So you have to read about it and you have to see what it is. That is the assignment. And then there is the lab assignment. These are the labs that you have to complete, uh, corresponding to what we have learned in this session, right? So that is what we had planned for today. If you have any questions, this is the time to ask. You can ask your questions in the live instructor interaction channel. Waiting for the questions. If you don't have questions right away, that's also okay. You can ask questions when you get them. So okay, digesting, that's okay. Is this slideshow posted? It will be posted in next 5 minutes. Yes. We share all the slides for the previous sessions also. If you check the announcement channel, you will actually find a OneDrive link. I upload everything to that OneDrive link. You will get the PCAP, the slides, everything. And within 12 hours, you will also get the recording if you want to go through, on some of the parts. Okay, thank you guys. So I think there are no questions as of now. You guys can, take your time to go through this, go through the labs. And, if you have any follow-up questions, just let me know. I'll post some links into resources channel. So keep an eye for that. And I'll also post examples of messages that you will see on your Windows and on your phone when you are trying to connect to uh, a network for which the certificate cannot be validated by your phone, right? So yeah. So guys, thank you for joining this session. Thank you for being a part of Wi-Fi Bootcamp. And I'll see you next week. Uh, so okay, guys. Thank you. Bye bye. Have a good day or a good night, depending on wherever you are in the world. Bye bye.